Hi, hello, governors once again, chapter governors. Objectives of this lesson. On completion of this lesson, you would be able to design and analyze the Watt governor, solve problems on Watt governor, analyze Porter governor, and solve simple problems on governors. Watt governor. Let us see the Watt governor. The simplest form of a centrifugal governor is a Watt governor. That means its working principle mainly depends on, that means its working principle is similar to the centrifugal governor. The arms of the governor, may be connected to the spindle in the following three ways. So here you can see the pivot P. Here you can see this is the pivot. P may be on the spindle axis. This is the spindle. On this, the pivot is lying. So this is one type of connection to the spindle. So here you can see, once again I will recall the construction of this Watt governor. Here is the sleeve which is going to slide along the spindle. This is the spindle axis, and these are the links. This is one link and another link. These are the two arms, and in this figure the two arms are pivoted on the axis of the spindle. So this is one, and next is the pivot may be on the spindle axis as shown in figure A, figure 1A, and sometimes the pivot may be offset from the spindle axis. It means this is the spindle axis and the pivot is away from the spindle axis, and here it is away, and here is also away from the spindle axis. And the arms when produced intersect at O as shown in figure. So if you see, this is the arm, this is the pivot, and this is the arm. If you produce onto the axis, they will intersect at one point, that is O. So this is the second method of connection to the spindle. And next is the pivot may be offset, but arms crosses with each other. The arms crosses the axis at P as shown in figure C. This is the first way of connecting the arms to the spindle, and this is the second way of connecting the arms to the spindle, and this is the third way of connecting the arms to the spindle. Here the arms are intersecting at the pivot itself, and in both these two cases the arms are away from, that means they are offset from the spindle axis, but they are intersecting. If you produce them, they are intersecting on the spindle axis only. This is the specialty of this Watt governor. And the Watt governor, so let us say m is the mass of the ball in kgs, and W will be the weight of the ball in newtons, that is mg, where m is the mass of the ball in kgs and g is the acceleration due to gravity, that is weight is equal to mg, weight of the ball is equal to mg, and T is the tension in the arm in newtons, and omega is equal to angular velocity of the arm, and ball about the spindle axis in radians per second. So R will be the radius of the rotation of the ball, and Fc will be the centrifugal force acting on the ball in newtons, that is equal to m into omega square r. That means simply we can say force is equal to, as we are having as per the Newton's second law, force is equal to mass into acceleration. And here also centrifugal force is equal to acting on the balls is equal to mass into angular acceleration, that is m omega square r, where m is the mass of the ball, omega is equal to speed, angular velocity, and r is equal to radius of rotation of the balls. Here you can see in this figure various points. From this point to pivot, this is the vertical height of the arm, whereas the length of the arm is different. So this is the height of the governor, whereas this is the pivot and this is the tension in the arm. So here is the radius of rotation of the ball, and this W will be the weight of the ball, and Fc will be the, which is away from the axis of the spindle, that is, and also balls, that is Fc is the centrifugal force. For corresponding to this, there should be some controlling force also there. So right, so h will be the height of the governor in meters. So once again, the terms, m is the mass of the ball in kgs, and then omega is equal to angular velocity in radians per second of the spindle along with the balls and arms, and r will be the radius of rotation, Fc will be the centrifugal force acting on the ball in newtons, and height will be the in meters, and T will be the tension in the arm, right? So this is all about. So now for equilibrium condition, the following forces are to be considered. The following forces are to be considered. Number one, centrifugal force Fc, capital Fc, this should be acting on the ball, and the tension in the arm. Number one is the centrifugal force away from the axis of the spindle, and the tension T will be the in the arm itself, and next is the weight of the ball acting towards the earth or to the ground. So here you can see this is the tension in the arm, and this is the centrifugal force, and this is the weight. So due to these three forces, one is the centrifugal force, one is the tension, and one is the weight of the ball, will keep the spin ball in equilibrium condition. So now let us take the moments about, taking the moments about O, that is say O, we have, if you take moments about O, Fc, about this point, if you take Fc into height, which will give you the clockwise moment, whereas W into radius of rotation, which will give you the anti-clockwise moment. That means, as per the equilibrium condition, the sum of the clockwise moments must be equal to sum of the anti-clockwise moments. Thereby, so centrifugal force will have clockwise moment, whereas the weight of the ball will have anti-clockwise moments, and whereas the tension T, the line of action of the tension is passing through the O, thereby the moment for tension is 0. So only the sum of, this is the sum clockwise movement, and this is the anti-clockwise movements. So both are equal to keep the ball in equilibrium condition, whereas there is no moment for tension of the arm. So W is equal to mg, as we are already aware that. So mg into r. So Fc is also, we are having m omega square r, that is m omega square r into h is equal to mg into r, and here m gets cancelled and r gets cancelled. So the remaining height of the governor h is equal to g by omega square. G by omega square. So here you can see this is the tension and this is the R, radius of rotation, for this, simply for this area. So this is the height of the governor is given by acceleration due to gravity by angular velocity of the ball, where g is equal to 9.81 meters per second square. So height of the governor is inversely proportional to the square of the speed. So here we conclude that in what governor? Simply the height of the governor is inversely proportional to the square of the speed. Right? So the speed of governor is independent of mass of the ball. Right? That means the speed is not depending on the mass, but whereas the speed is depending on the height of the governor. If the speed of the governor increases, height will be decreased. If the speed of the governor decreases, height will be increased. So this is the idea. This is all about the analysis of Watt governor. So let us see one simple problem in this on Watt governor. Let us have. So here you can see the calculate the height of Watt governor. Calculate the height of Watt governor when it rotates at 60 rpm. That is 60 revolutions per minute. Also find the change in vertical height when its speed increases to 61 revolutions per minute. So simply, as we are having the formula, here one speed is given to you in revolutions per minute and another speed also given for us in revolutions per minute. By using angular velocity formula 2 pi n by 60, omega is equal to 2 pi n by 60, angular velocity omega is equal to 2 pi n by 60, we will get our solution. Let us see the solution. So governor speed is 60 revolutions per minute. If its speed increases to 61 revolutions per minute, required to calculate in vertical height when speed increases. So angular speed omega 1 is equal to 2 pi n1 by 60. That you will get 2 pi radians per second. And for this speed, for this 60 speed, the height of the governor h is equal to h1 is equal to g by omega 1 square. That is 9.81 by 2 pi square is equal to height of the governor is 0.248 meters. This is the one answer. And similarly, for when speed increases to 61 revolutions per minute n2, so angular speed is equal to 2 pi n2 by 60, which will give you 2.04 pi radians per second. Whereas the height of the governor h2 is equal to g by omega 2 square, that is g is equal to 9.81 and omega 2 is equal to 2.04 pi square, that is 0.24 meters only. Thereby the change in vertical height of the governor is equal to h1 minus h2. As we are aware that when the speed is less, height of the governor is more. When the speed is more, height of the governor is less. Thereby, at 60 speed, the height is more, whereas at 61 speed, 61 revolutions per minute, the height will be less. Thereby, there is a change in the vertical height. There is a change in the vertical height of Watt governor, that is h1 minus h2 is equal to 0.008 meters. That is 8 mm difference is there. Right? With this, we can conclude one thing. Whenever the speed is less, the height of the governor is more. Whenever the speed is more, the height of the governor is less. That means the height of the governor is inversely proportional to the speed of the governor. So, right? This is the conclusion for this Watt governor. Let us see once again. So next, Potter governor. Here you can see the Potter governor. Only the difference. This is also centrifugal governor. When comparing to this previous Watt governor and this Potter governor, is only the difference is here there is a dead weight on the spindle. That means the sleeve, over the sleeve there is a dead weight which will bring the governor to the normal position. That means to the rated speed, right? So here you can see this is the sleeve and this is the spindle, and this is the dead weight. Weight of the dead weight is equal to W. And now here in this case, these are the two links, and this is these two are the arms, and which is pivoted at point P, B, and here is the height of the governor, and it is the R is equal to radius of rotation, and W will be the weight of the ball, and whereas Fc is equal to m omega square, that is centrifugal force. These are the balls. So here, whereas in the previous case, now it is only the difference is here in this case is the dead weight only. This is the dead weight is there. So this dead weight will be split at this position and this split position. That means here it is W by 2, here it is W by 2. Right? So that is the only difference. And the same as in the previous Watt governor, spindle is there, arms are there, and links are there, balls are there, and they were pivoted at this position, but only this dead weight is extra in this Potter governor. Right? So now let us see the analysis of Potter governor. Here are the forces acting on different parts. Here is the tension in the T1 is the tension in the arm, and T2 will be the tension in the link. Whereas in the previous case, there is no tension in the link, but here in this case, there is a tension in the link also. And here Fc will be the centrifugal force on in the ball, and W, small w, will be the weight of the ball in which is equal to mg, small mg. And now here it is dead weight W by 2. It is just like a simply supported beam. We can split this. We can split this W by 2 here in this side and W by 2 on the other side. So W, capital W, is equal to weight of the dead weight. That means dead weight of the dead weight into acceleration due to gravity. The capital W is equal to capital W into G. And only half of this will be shared. So in this problem, in this analysis, let us have taking moments about instantaneous center. Let us extend this one and also extend this one. This will give you the instantaneous center, and we have to take moments about this instantaneous center. If you take the moments about this instantaneous center I, the moment for T1 will be 0, whereas there is a moment for T2, and there is a moment for W, and there is a moment for centrifugal force, and also there is a moment for W, capital W by 2. So let us see. And this is the angle of arm with respect to spindle axis. So this will be the angle beta with respect to spindle. So now after taking this, so as we are aware that in order to keep the ball in equilibrium condition, the sum of the clockwise movements must be equal to sum of the anti-clockwise movements. So thereby here in this case, about this point, if you take moments about this point, this will give you anti-clockwise. That means centrifugal force will give you anti-clockwise moments, number one. And whereas the weight of the ball will give you clockwise movement, and half of the weight of the dead weight will give you also clockwise movement, whereas T also will give you, T2 will also give you clockwise movement, right? So that means if you take a triangle forming, and this will be the alpha, this will be the beta, so sum of the clockwise movements must be equal to sum of the anti-clockwise movements. So FC into the distance CD, that is this distance, this is distance CD is equal to, and this will give you clockwise movement, and this is also going to give you clockwise movements, and we are going to neglect this small value. That means tension in the link will be very small. That's why we are going to neglect this one. So W into ID, this is the distance, plus W by 2 plus into this distance IA, whereas IA is equal to ID plus DA. That means from here AD plus DI. So if you bring this CD, these two are the clockwise movements, only this will give you the anti-clockwise movements. So that's why W into perpendicular distance ID plus W by 2 into AI, which is also equal to AD plus DI. So if you bring this CD to this side, FC is equal to WID by CD plus W by 2 into AD by CD plus DI by CD. Let us see in this triangle. Let us see in this triangle, ID by CD, ID by CD. This is the alpha. So ID by CD. This is the opposite side. That means sine alpha you will get. Sorry. This is adjacent side. This is opposite side. Opposite side by adjacent side will give you tan alpha. That's why ID by CD is nothing but the tan alpha. That means W tan alpha you will get. And whereas AD, whereas AD by CD, this is also opposite side to this beta angle. That's why tan beta plus DI by CD, that is tan alpha. So we finally will get, after observing all these moments about this, so W to FC is equal to W tan alpha plus W by 2 tan beta plus tan alpha from this force figure, right? So FC, if you take common, tan alpha as common, if you see here in this case, tan alpha here is there, tan alpha is also here there. If you bring this bottom, that means common. So W by 2 into tan alpha into tan beta by tan alpha plus 1 you will get. So tan alpha is equal to W plus W capital W by 2 tan beta by tan alpha plus 1 you will get. So if you take tan beta by tan alpha as a constant, so K tan beta by tan alpha is equal to K, then FC is equal to tan alpha plus W plus capital W into K plus 1, right? This is the where K is equal to tan beta by tan alpha, where K is equal to tan beta by tan alpha. So let us see in terms of radius R and height of the governor H. In terms of radius and height of the governor, tan alpha is equal to small r by h, small h, that will give you. So finally centrifugal force Fc is equal to, also we are having m omega square r. So here is the one formula, Fc centrifugal force is equal to tan alpha into small w plus capital W by 2 into K plus 1. If you take K is equal to tan beta by tan alpha, as we are also aware that R is equal to, if you see, so this will be the R, this will be the R, whereas from here to here is the H. So tan alpha is equal to R by h. So tan alpha is equal to r by h. This is one equation and this is second equation. And also centrifugal force is equal to Fc is equal to m omega square r. Already we are aware that this formula. So this is the third equation. From equations 1, 2 and 3, after substitution of Fc value and after substitution of tan alpha value, you will get like this: m omega square r into small w plus capital W by 2 into k plus 1 into r by h. And now here r gets cancelled, right? So for further simplification equation, we conclude omega square is equal to r gets cancelled, as you have seen. R gets cancelled, and m, if you bring toward this side, or if you substitute m value as w by g, then you will get omega square is equal to capital W plus small w plus w by 2 capital W by 2 into k plus 1 by m into 1 by h, where omega is equal to angular speed of the governor in radians per second, and small w is the weight of the ball of the governor in newtons, and capital W weight of the governor sleeve, and m is the mass of the governor balls in kgs. From the analysis we can see, replacing small w with small mg and capital W with capital Mg, the equation for angular speed becomes omega square is equal to m plus capital M by 2 into k plus 1 by m g by h. So this is the formula in terms of, whereas the previous case is in terms of weights, and mass of the ball and speed, and whereas this will be the in terms of masses. So when the length of the arms and the suspension are same, then and are at equal distances, r is equal to h, then k is equal to 1. So that the formula will become, for r is equal to h and k is equal to 1, then the formula will become different. So finally omega is equal to m plus capital M by small m into g by h. That is the final formula that you will get. So when the lengths of the arms and suspension are same and are at equal distances, in such cases r is equal to h and then k is equal to, that means this will happen, this suspension if you same and length of arms are same, this will happen for offset pivot. That means if the balls are connected to the spindle through arms by means of offset pivot, in such cases this will take place, right? So this is all about the formulas that we are having already. This is the analysis of the Porter governor. As we are already aware that the working of Porter governor is similar to the working of centrifugal governor, and only the difference is the dead weight over the sleeve. That is only the difference. So let us have some of the problems over the Porter governor and also Watt governor. Once again, a Porter governor have two balls each weighing 26 newtons, that is weight of the ball, small w, are joined by four links of length. That means arms as well as the links are of the same length. So then 300 mm each, and a dead weight of 320 newtons is used on sleeve center. At the sleeve center, if the radius of rotation is 240 mm, find the equilibrium speed. So here one thing is the links are of the same length, number one. Number two is used at the dead weights are at sleeve center only. So that's why, so weight of the ball small w is equal to 6 newtons and the length of the links is equal to 300 mm, and dead weight of sleeve w capital W is equal to 320 newtons and radius of rotation is 240 mm given, and required to evaluate equilibrium speed is height of the governor, which is equal to L square. That means simply you can see the governor, L square minus R square, length of the link square minus R square, that will give you the height of the governor H, right? This is the R and this is the length. We need H. So L square is equal to R square plus height square, whereas height square is equal to L square minus R square. That you must remember once again. So that is the idea. Height of the governor H is equal to L square minus R square, whereas L is equal to 300, whereas 300 L square is equal to 300 square minus 240 square is equal to, where height of the governor is 180 mm. And let omega will be the equilibrium speed in radians per second. Then omega square is equal to small w plus capital W by 2 k plus 1 by m into 1 by h. So here you can see, as the length of the arms are and links are same, so then k is equal to 1, number 1. So m is equal to w by g, whereas that is equal to w is also there for us, 26 by 9.81, that is 2.65 kg. So if you substitute 26 plus 320 by 2, whereas I told you already this length of the links is same, that's why k is equal to, that is tan beta by tan alpha is equal to 1, because alpha and beta is same. That's why tan alpha by tan alpha is also 1, or tan beta by tan beta is also 1. That's why k is equal to 1. So thereby 2.65, m is equal to 2.6. After substitution, omega square is equal to 725.37. That is omega is equal to 26.93 radians per second. So to evaluate speed in revolutions per minute, so omega is equal to 2 pi n by 60, or n is equal to 260 into omega by 2 pi. That will give you in speed is equal to 257.16 revolutions per minute. Like this you can calculate for Porter governor. This is one type of problem. That means equal lengths of links, and also the dead weight is at the center of the sleeve, not away from the dead weight is not away from the center of the sleeve, but here it is at the center of the sleeve. That's why R is equal to H, it will become, whereas the length of the links are same, that's why k is equal to 1. That you must remember, right? The final answer will be 257.16 revolutions per minute. Otherwise, in terms of angular speed, 26.93 radians per second. Next, problem 2. A Porter governor has balls of mass 3 kg. Mass here is he has given 3 kg attached to a central load of 20 kg. Central load of mass 20 kg. It has equal arms of each 200 mm long, pivoted on the axis of the rotation. So the radius of rotation of ball is 150 mm when the governor begins to lift, and is 180 mm when the governor is at maximum speed. So complete the maximum speeds and compute, sorry, this is the not complete, this is the compute the maximum speeds and the range of speed. Simple, where it is very so here equal arms, that's why k is equal to 1, and the dead weight is pivoted on the axis of rotation, thereby r is equal to h. So, and also two conditions are there, radius of rotation is one is 150 and another condition is 180. So it is at maximum speed, it is at, simply we can say it may be the minimum speed. So here you have to calculate, say, let us see, length of the arms is equal to L is equal to 200 mm. At maximum speed, radius of rotation R1 is equal to 180 mm, and H height is equal to L square minus R square is equal to H1 is equal to 87.17 mm, that is 0.08717 meters. And similarly for given condition k is equal to 1, because the lengths of the links are same, that's why k is equal to 1, and the angular speed omega 1 is equal to under root of small m plus capital M by small m plus capital M by m is equal to into gh1 after substitution. This is the formula we must remember in terms of masses, where k is equal to 1, r is equal to h, and in such case this is the formula that we must remember. M is equal to 3 kg and 20 kg by 3 kg into 9.81 by 0.08717, that you will get omega 1 is equal to 27.37 radians per second. In terms of speed in revolutions per minute, if you take n1 is equal to 60 omega by 2 pi, that will give you finally 280.63 revolutions per minute. So right, this is the maximum speed. Next is when the governor begins to lift. When the governor, that means it is at lowest position, that means minimum speed, radius will be r2, that is 150 mm. If you substitute h2 is equal to L square minus 150 square, r square is equal to 132.3 mm height, thereby 0.132 meters. In such case, in such speed, angular speed is equal to omega 2 is equal to m plus capital M by small m into g by h2. After substitution, 3 plus 20 by 3 into 9.81 by h2, you will get w2 is equal to 23.84. So n2 is equal to, then after substitution in omega equal to 2 pi n by 60, you will get n2 is equal to 227.8 revolutions per minute. Whereas the range of speed, that means maximum speed minus minimum speed, equivalent speed is equal to 280.63 minus n1 is equal to 280.63, whereas n2 is equal to 227.8, that you will get the range of that means the difference of the speeds, or the range of speeds 52.83 revolutions per minute. This is the idea of the Porter governor whenever it is at lowest position, at highest position, right? This is the formula that you can solve this very easily, right? So friends, with this we have completed in this lesson the analysis of the Porter governor, and one simple problem we solve, and also analysis of the Watt governor also we completed, Porter governor also completed, different formulas we have seen, and here in this case also some of the problems on Porter governor and one problem on Watt governor we have seen. And now let us see the summary of this lesson, today's lesson. So in this lesson we have discussed about analysis of Watt governor, which is also similar to the centrifugal governor, and only the difference, there is no dead weight in Watt governor, right? The calculation of speed, height, etc. of Watt governor also we have seen. And similarly, in this lesson we have discussed about analysis of Porter governor also we completed, solved some simple problems on Porter governor also, and two Watt governor also we have seen in this lesson, right? Let us see the small quiz on this lesson, today's lesson. So angular speed omega is equal to, I think it is very easy because this formula we have seen in physics itself. That's why omega is equal to, simply we can have 2 pi n by 60. Right? 2 pi n by 60. This is the answer. Next is, in what governor? Speed of governors is independent of. In what governor speed of is independent of? Simply we can say it is independent of mass. It is the independent of mass. Right? It depends on the height only. So that's why mass of the balls. Right? This is the answer. And next, angular speed of Porter governor is given by. Angular speed of Porter governor is given by. So this is the formula, omega square or omega square is equal to small w plus capital W by 2 into k plus 1 by small m into 1 by h. This is the formula that you must remember always for Porter governor. Right? Let us have a small assignments also. If anybody want to solve these assignments, you can solve. Answers also given in this lesson. So assignment, the length of the upper arm, the arm of what governor is 400 mm and its inclination to the vertical is 30 degrees, and find the percentage increase in speed if the balls rise 20 mm. If the balls rise 20 mm. Previously, we are having the formula that is height is equal to C we are having one formula that is G by omega square. Height is equal to G by omega square. That formula you can use here also, right? And you can solve this problem easily. Inclination upper arm length is given to you, whereas inclination is also given to you. That means simply as per Porter governor's, if you observe, alpha is equal to 30 degrees. In such case, you can calculate by using arm length, radius of rotation also you can calculate, and height of the governor also you can calculate with this, right? You can calculate radius of rotation by using this formula. That means sine alpha or sine 30 degrees is equal to r by length of the arm. Then you will get your radius of rotation, and also h also you can calculate. And if the balls rise 20 mm, that means range of speed, difference in the heights h1 minus h2. That means you have to calculate h1 and then also h2 you have to calculate. After calculating h1 and h2, then you can have the percentage increase in the speed also, right? So that is the idea. Next, assignment 2. A loaded governor of the Porter type has equal links 25 centimeters long, pivoted at the axis. Weight of each ball is 3 kg, and the weight of the central load is 14 kg. The ball radius is 15 centimeters when the governor begins to lift, and the 20 centimeters at the maximum speed. Right? Determine the maximum speed and range of speed if the friction at the sleeve is equivalent to 1.5 kg. Find the maximum and minimum speed or the range of the speed. It is similar to, more or less similar to the previous problem. It is Porter governor problem. You can solve this also very easily. And third one, in an engine governor of the Porter type, the upper and lower arms are 20 centimeters and 25 centimeters long and pivoted on the axis of rotation. The central load is 15 kg. The weight of each ball is 2 kg, and the friction of the sleeve together with the resistance of the operating gear is equal to the weight of 2.5 kg at the sleeve of the limitedly inclination of the upper arms to the vertical or 300 mm, sorry 300 and 400. Find taking friction into account range of speed of the governor. Right? This will be also solved as per our previous problems. Right? So next problem is, I think it is last problem. A loaded governor prototype has equal arms and links each 250 mm long. The mass of each ball is 2 kg and the central mass is 12 kg. When the ball radius is 150 mm, the valve is fully open. Right? When the radius is 185 mm, the valve is closed. Find the maximum speed and range of speed. So radius is maximum and the valve is fully open at 150 mm radius, whereas 180 mm it is fully closed. 150 mm fully open, 185 mm fully closed. That means at maximum speed it is fully closed, at minimum speed it is open. That is the idea. So these are the assignments that we are having in this lesson. So thank you for patient hearing of this lesson. So thank you.